Hello, this is Paul from Foresight Tech. In this video, let's prove Theorem 4.4.3, which gave us a special linearly dependent set of vectors. See, it's like this is special. R greater than n. Okay, so n is the dimension of the space, right? Euclidean space. If the number of the vector in the set is more than the dimension is greater than the dimension of the space, and then this set should be linearly dependent. Let me give an example. Okay, see, if I look at it, 2 space, the dimension is 2, right? If I give you any 3 vectors, the number of the vectors 3 is greater than the dimension 2. Therefore, the theorem says this set should be linearly dependent. So how to say? How to prove? We use the theorem we just learned, 4.4.1. We set up a linear system and to solve the system. If we find only trivial solution, means linearly independent. If we find a non-trivial solution, that means linearly dependent, right? Okay. So now we set up the system. And then we try to solve this system. How to solve this? We can use the matrix form. See, this is just this A times X equals 0. We can make it into a matrix multiplication. Where is A? So A is V from V to V R. Of course, we need to make sure. So this is the column. For each vector, we set up in the column form, column vector. Okay. See, therefore, we put all the vector, the column vector together, we form a matrix A. And then what is X? X is the unknown vector. Okay. So it is K1, K2, 2, KR. And you easily verify. So this matrix is multiplied by this X vector, we definitely get it. Like this is a row, this is a column. Okay, common together is the linear combination. Then how to solve this? We only need to look at the size of the system. So how big is A? See, how big is A? So I look at A. We have N. No, we have R columns, right? How many rows of A? How many rows? We need to look at the dimension of the vector V. V belongs to n space. Okay, so therefore this is n rows and R columns, right? Good. We get the size. So A is n by R. Okay, that's super important. It means what? It means n equation. How many unknown? R unknown. This means n equations and R variables. Let me say. Okay. By the definition, by the condition, we say the number of R is greater than number of N. See, R is greater than N. It means R greater than N means more variable than the equation, right? The number of variable is greater than the number of equation. Okay, so we simply say more variables than the equations. Yes, so because this system is a homogeneous system, always consistent, and we have more variable than the equation. Okay, therefore we know free variable exists, right? Definitely. Okay, so we'll get this. We will get free variables exist. So therefore we have infinitely many solution, right? So because of free variable means infinitely many solution. So this infinitely many solution means non-trivial solution exists. Okay, so it means you see the linear system. We set up a linear system and we find a non-trivial solution exists by the theorem 4.4.1. Okay, so therefore, by the theorem we just learned, so the set of vectors are linearly independent, right? So L equals this is linearly non-trivial solutions, therefore linearly dependent. Okay, that's the result. Yeah, thank you.